Hi guys, Mr. Starry again. What I want to look at today is, can we write a slope-intercept form equation from a graph? Now, before we were given information like the slope and y-intercept and we were asked to write the equation. Now we have to kind of discover that information or pull it from this graph. Remember, the two pieces of information I need for a slope-intercept equation are the slope, m, and the y-intercept, b. So once I find those two things, I then can just kind of fill in the y equals and the x around it. But how do we do that? We have to pull that from this graph. Well, I always like to start with the y-intercept because we're looking for where does my line cross the y-axis. Well, let's follow our line, and we notice it crosses right here at +3. So it is wise to mark that with a dot or a point. And I'm going to make note of that my y-intercept is is 3. Okay. If you're being super technical, it would be 0,3. But we know that we're not going to put an ordered pair here. We're going to put a number. So, we can keep this in the back of our mind, but what we're really going to want here is a +3 for our equations purposes. Now, the slope is kind of the more challenging of the two to get because I need another ordered pair that I can travel to and from here. Remember, we need to consider rise over run, and I need to pay attention to how I'm moving because of positive and negative and stuff like that. All right, well, let's travel. What I like to do is I like to start at the point I already have drawn, and I like to just kind of look through my line for the next ordered pair that I can identify. So if I kind of go in the upward direction here, you don't really see much. So why don't we go down here? And if I just kind of follow my line, it looks like, ooh, right here's an identifiable point that I can use. The nice part about this is we don't even have to identify it. We can just kind of, oh, it's a point I can identify with my eyes. So, that's going to be a point that works. Now, the last part of this is, hey, can we just find the slope of this line? Well, using rise and run, we can do that. So let's start at our bottom point and work towards our top point. So we're going to rise 1, 2, 3 in the upward direction. So I know that's a +3 for my rise. For my run, I continue from where I was, and I run 1 to the right. That's a +1. Remember, to the right is a positive movement, to up is a positive movement. Well, my rise over my run. My rise over my run is going to be my slope. So 3 over 1 is my slope. And I can actually do a little bit better than that because we know we want it as clean as possible when we write this as an equation. 3 over 1 is just the whole number 3. I have my slope, I have my y-intercept. Now it's just a matter of getting them in the right spot. And ironically, they're the same number in this case, so kind of a bad example to start with, but we'll roll with it. So we're going to write in slope-intercept form now. So y equals my slope, which is 3, followed by the x, plus 3 because it was at +3 on my y-axis. That is the equation for this line in slope-intercept form. Let's take a look at another one, a little faster now. Again, we're looking for the y-intercept and the slope. And again, I like to start with the y-intercept even though it comes second in my equation, just because it's kind of the easier one to see. So where do we look? Oh, right here. -2 is where my y-intercept is located. And again, that's a location, but I know for my equation, I'm just going to write that number in there. So just the number here is going to be okay. Now, again, we're going to look across our line. And again, we're just looking for any other ordered pair that we can visually identify. And we actually don't even have to identify it if we don't want to. So let's look down our line and, ooh, looks like another point of intersection here. Now that we have our other point, let's find our slope. Well, let's rise. Well, we can start at the bottom one and work up. We did that last time, so how about we start at the top one and work down? So let's see, we're going to rise down 1. So that's actually going to be a -1. Okay, I'm now in line with my other point, so let's run to it. 1, 2, 3, 4. 4 to the right, so down 1 is -1. 4 to the right would be +4. So let's write my fraction as rise over run. My rise was -1. My run was +4. I'm now ready to write my equation. Y equals my slope, which is -1/4, x. Now notice this is -2, so I can kind of cheat a little bit here and say -2 and write -2, but as it sits in my equation, this is going to be y equals -1/4 x minus 2. So again, we kind of trick ourselves into writing minus, but we say negative. Let's take a look at a couple more. Again, we're looking for my y-intercept, b, and my slope. So again, we can kind of move a little quicker now that we kind of have the idea. My y-intercept is at -1. That's where my line is crossing the y-axis. My slope, well, again, I need another ordered pair, and it can be any ordered pair that is identifiable by this line. So let's travel. Looks like we don't have to go too far because it's the very next one. All right, I'm ready to do rise and run. So let's do it. We're going to rise 1. So that's +1. We're going to run +1 to the right. So my rise and run this time is actually 1/1, or just the whole number 1. I'm ready to write my equation now. Y equals, my slope is 1, x, and it's -1. So again, I can kind of cheat and say -1. However, I just wrote -1. Even further, y equals 1x minus 1. That would technically be okay. But actually, just like we can put that 1 there, we can actually take it away. So y equals x minus 1 would also be an appropriate answer here. For our next one, again, notice guys, it's the same strategy over and over and over again. Just little caveats start to happen, like, you know, a coefficient of 1 and some of the stuff that we're about to see. Let's find our y-intercept. Let's find our slope. Well, where does my line cross the y-axis? At 0. What's my slope? Well, mark that. Let's travel my line. Oh, that one doesn't hit. Let's keep going. That one just misses as well. Oh, looks like here's a point that I can use. I'm now ready for rise and run, so let's do it. Rise 1, 2, 3. So I went 3 in the positive direction. And I run 1, 2, 3, 4 to the right, so that's +4. My rise is 3, my run is 4, so my slope would be 3/4. I'm now ready to write slope-intercept, so let's do it. Y equals my slope, which is 3/4, x plus 0. Again, plus 0, you know, it's technically correct. However, we can do a little bit better because we know that anything plus 0 is just that thing. So we could actually clean this up a little bit and just write this as y equals 3/4 x. These last two examples are kind of special cases, if you will. Notice that one is horizontal and flat. Notice one is vertical and kind of up and down in nature. So again, we can kind of proceed as normal here. You know, look for our B, look for our M. Well, in this case, my B is, or my y-intercept is 4. 1, 2, 3, 4. My slope, now, you can kind of use your intuition here, or you could do it kind of formally, how we've been doing it. Either way, it's going to work out. You know, we know that lines that are flat have 0 slope, so I could go ahead and write a 0 there and be done with this one as far as finding slope. Or I could take the more technical route and find an ordered pair. And that would be okay too, because here's why. All right, let's do our rise and run. How much do I rise? I don't rise anything, so my rise in this case would actually be 0. Over, how far did I run? Well, just 1. Well, if I have a numerator of 0, that means I have the whole number 0. So technically speaking, we could go either route with this. We could take the more step-by-step approach, or just use our intuition and say, hey, look, you know, this is a flat line, so it has to have 0 slope. All right, well, y equals 0x +4, so +4. Well, I know that 0 times anything is just going to be 0, so y equals 0 plus 4. And even further, 0 plus anything is just going to be that thing, so y equals 4. So technically we have like this itty-bitty slope-intercept form equation, but it still technically is. It kind of began as it, and you know, we just kind of clean things up until we have our nicest looking possible equation. Now, the last one is kind of like a special case. We see that it's undefined slope, it's up and down. And really, kind of to get to the point with this one, whenever we see undefined slope, we know we're going to have x equals something. It's kind of the best way to get right to the point. You know, we see up and down, undefined slope, we're going to have x equals. Everything else is y equals, you know, y equals, even this one, y equals 4. All the ones before this were y equals something x plus or minus something. You know, when we see a vertical line, we just assume x equals. It's kind of the most straightforward way to think about it. But x equals what? Well, what is x equaling? Well, on my x-axis, where am I? 1, 2 to the left. X equals -2. And believe it or not, we're done right there. That's all I have for you today in this one, guys. I hope you learned something. We'll talk to you in the next one.